Welcome to the course on Python for data analytics, machine learning, and generative AI. This session is on generative adversarial networks, also known as GANs. GANs are one of the most fascinating technologies in artificial intelligence. They are used to create realistic images, videos, and other digital content. For example, GANs can generate artificial human faces, realistic artwork, synthetic photographs, fashion designs, and even deepfake videos. But how can a computer create such realistic content? The answer lies in a clever idea where two neural networks compete with each other. This competition helps the system improve over time and produce very realistic outputs. In this session, we will cover what are generative adversarial networks, the generator, the discriminator, the competition between generator and discriminator, training process and applications of GANs, challenges in GANs, and training and ethical considerations. Generative adversarial networks are a type of deep learning model used for generating new data. The term generative means the system can create new content. The term adversarial means the two models compete with each other during training. GANs consist of two neural networks, generator and discriminator. These two neural networks work against each other. The generator tries to create fake data that looks real. The discriminator tries to identify whether the data is real or fake. Through this competition, both networks improve over time. Eventually, the generator becomes so good that the fake data looks almost identical to real data. The most interesting part of GANs is the competition between the two networks. The generator tries to fool the discriminator by creating realistic data. The discriminator tries to catch the generator by detecting fake data. So, the generator improves to create better fakes. At the same time, the discriminator improves to detect those fakes. This process continues again and again. Over time, the generator learns how to create highly realistic data. This competitive learning process is what makes GAN so powerful. Let us first understand the generator. The generator is responsible for creating new data. It starts with something called random noise. Random noise is simply a collection of random numbers. The generator uses these numbers as input and transforms them into something meaningful. For example, a random set of numbers may be transformed into a realistic image of a human face. At the beginning of training, the images created by the generator usually look very unrealistic, but as training continues, the generator learns how to produce better and more realistic outputs. The discriminator acts like a detective or judge. Its job is to examine data and decide whether it is real data from the training set or fake data created by the generator. The discriminator receives two types of inputs: real examples from the data set and fake examples created by the generator. It analyzes this input and tries to correctly identify which ones are real and which ones are fake. During training, the discriminator becomes better at detecting fake data. Generative adversarial networks, or GANs, work like a continuous game between two neural networks called the generator and the discriminator. The generator tries to create fake data that looks as realistic as possible. At the same time, the discriminator tries to identify whether the data is real or fake. This creates a competitive learning process where both models constantly improve. As the generator gets better at fooling the discriminator also becomes better at detecting fakes. Over time, this competition leads to the generation of highly realistic synthetic data. The GAN learning process happens through a repeating cycle of creation, evaluation, and improvement. First, the generator produces fake data using random noise as input. Both real data and generated data are then given to the discriminator for analysis. The discriminator predicts whether each sample is real or fake. Based on these predictions, the system calculates error and sends feedback to both networks. This feedback helps the generator create better data and helps the discriminator improve its detection ability. This training process repeats thousands or even millions of times. With each cycle, the generator improves its ability to mimic real-world data. Eventually, the generated outputs become so realistic that they are difficult for humans to distinguish from real ones. In some cases, the generated images can look almost identical to real photographs. This means the system can create completely synthetic faces or objects that do not exist in reality. Such capabilities demonstrate the remarkable power of adversarial learning models. GAN technology is transforming many industries through the generation of synthetic data. In image enhancement, Gans can convert blurry or low resolution images into clear, high quality ones. In art and design, they allow creators to generate new styles and innovative visual content. In medical imaging, synthetic data helps train diagnostic systems without exposing sensitive patient data. The entertainment industry uses GANs for video creation, animation, and realistic visual effects. These applications show how generative models are expanding creative and technical possibilities. Despite their powers, GANs also come with technical challenges. One common issue is mode collapse, where the generator repeatedly produces similar outputs instead of diverse samples. Another challenge is training instability because the generator and discriminator must remain balanced during learning. If one network becomes too strong, the training process may fail or become unstable. Researchers continuously experiment with new architectures and training techniques to overcome these limitations. Improving stability and diversity remains an important area of research in generative AI. Let's now look at the real world impact of synthetic media created using technologies like generative adversarial networks or GANs. While these technologies can produce highly realistic images and videos, they also raise serious ethical concerns. One major issue is the creation of deepfakes, where fake videos or images appear almost identical to real ones. Such content can easily be misused to spread misinformation and manipulate public opinion. Because of this risk, there is an urgent need for responsible AI policies and regulations. Advanced detection tools are also being developed to identify and control AI generated fake content. Generative AI has been evolving rapidly, transforming many industries and applications. Technologies such as generative adversarial networks use a competitive learning process between two models to generate realistic data. This approach has enabled breakthroughs in areas like medical imaging, digital art, and synthetic data generation. Over time, generative AI has become more powerful and capable of producing highly detailed outputs. Today, the field is moving towards newer techniques such as diffusion models. These models represent the next major step in generating high quality, and more controllable AI content. Let's summarize. Generative adversarial networks represent a fundamental evolution in machine learning. By forcing models to compete, we have transitioned AI from tool that merely categorizes the world into an engine capable of imagining entirely new realities. As architectures continue to evolve, GANs will fundamentally change how we create, work, and interact with digital content. Thank you.